So guys, hey everybody, my name is Ankit Singh, student of PE Computer Science and Engineering, and today we are going to discuss about raster scan display, which is from the subject computer graphics and image processing. So guys, here the introduction to the raster scan displays. The raster scan displays are fundamentally uh, display technology which is used in the computer graphics. They represent image as the grid of the individual pictures and elements are called pixels that are printed sequentially into the display devices. So guys, there are basically two methods by which we are gonna show into the display technologies. One is random scan, second one is raster scan. So random scan is something different, but now we're going to talk about the raster scan. Raster scan is the display technology in which uh, the image is formed by the pixels or the small dots which is formed above the image or the screen. So first one is the pixel based representation, as I told you. So the pixel grids, the raster images are composed of the 2D grids of the individual pixel, each with its own color and the value. The second one is addressable elements. Each pixel can be individually addressed and modified to create the desired image. So as the each pixel has its own unique coordinates or the addresses where it is placed so that the particular image is formed, and the resolution. The number of pixels determines the resolution of the raster image. So resolution is nothing but the detailings. So as many as the pixels are present in the picture, it means more detailings are present. So yes, the line scan and frame buffers. So scan lines. So the raster scan display paints the image in the horizontal scan at a time. So here's the frame buffers. A frame buffer is nothing that stores the color values of the each pixel in the display. So refreshing the display. So the frame buffer repeatedly scans and continuously refreshes the image display. This helps to get more clarity into the images. So the rasters can display are present inside the different devices. So these are all the devices where we can see the raster scan displays. First one is the CRT or cathode ray tube. So like earlier days we used to see the monitors or the televisions which have the like bigger screens. So they are the CRTs in which there some one electron beam is fired using the electron gun to the screen where some chemicals like phosphorus is being used to form the image. Second one is LCD, which is liquid crystal displays, which is used as a matrix of individual controllable liquid crystal pixels. And the second one is light emitting diode, which is the latest technology is being used. The LED displays use an array of the pixels individually lit into the LED. So guys, here this is the addressing pixels into the raster scan. So guys, addressing of the pixel is very important aspect in the raster scan displays. Like as I told you before, like that into the pixel placing often help us to get the more detailed images, which help us into the data analysis. So here's the first technique, which is called the row major order. So the row major order we have already studied in our uh, previous semesters or the when we use it in eitherly into the like uh, displaying of the pixels into the left to right or top to bottom order. So this is one criteria. Second one is to the XY coordinate system, which is used very often, or it is very useful nowadays. This is the method is used by everywhere. So each pixel is identified by its column X and the row Y coordinate systems. Like at the top left corner, it is considered as 0, 0, and the entire screen being considered from whatever the coordinates are there. By using that, we place the pixels according to that. And the last one is the frame buffer mapping. So the frame buffer mapping stores the pixel data into the 1D array format, and this and the helps the form to the images into the 2D displays and all. So here's the raster scan conversion algorithm. First one is Bresenham's algorithm, which is the efficient algorithm to draw the lines into this using these pixels. Second one is polygon filling, scans each line of and determines each pixels within the polygon. And the third one is the texture mapping, so maps the texture images into the 3D surfaces, which often helps to form the images. So here's the advantage of the raster scan displays over the random scan displays. First one is high resolution images being formed like HD images. As it is written, the raster scan display can achieve the high pixel resolution and detailing every images, which helps into the analysis of the image or taking out the information from the image very easily. Second one is the full colored capability. Each pixel can be assigned a unique color and allowing the vibrant phosphoric in the photorealistic image. As I told you, detailings. And the third one is efficient processing. Dedicated hardware can repeatedly update and refreshes the raster scans. So here's the application of the raster scan graphics. So first one is digital imaging. That the raster scan displays help us to form the more detailed this digital image, and the clarity of the image is very high. So the editing, photo editing, and the image manipulation gets very easier. And the second one is the video displays in the television, computer monitors, and smartphones, which can make the displays or the things which we are going to visualize or see more realistic, which help us to interact very more often. And the third one is the computer games. The computer games like the 3D realistic environments and the animated characters. These are the things which helps the raster, which the raster scan display has been used, and helps to improve the interactive of the user. And the third one is visualizations. Apart from these domestic or the home applications, we use it into the data plots and the medical science and the scientific simulations also. So guys, this is for the today's presentation. We are gonna meet in the next video.